Hey guys, hope everybody's doing well. It's Dr. D. I wanted to discuss a problem, walk through a problem here that I got some questions about that we had on a recent quiz. And here's the question. I'll just read it aloud to start us off. In a survey conducted by the Gallup organization, respondents were asked, what is your favorite sport to watch? Football and basketball ranked number 1 and 2 in terms of preference. It's from the Gallup website. That's just motivation, right? Here's the actual question then. We're going to run a random experiment. Assume that in a group of 10 individuals, 7 prefer football and 3 prefer basketball. A random sample of 3 of these individuals is selected. Part A wants to know what the probability that of the 3 we selected, that exactly 2 of them prefer football. And the other part B is what is the probability that a majority, meaning either 2 or 3, prefer football. All right, now what we have here is a random experiment, right? And by that we mean this is a process. And we can define all the outcomes. We can specify the sample space that we're drawing from, and when we actually select 3 individuals, then we'll have a sample point that we're selecting. In this case, the outcome is a numerical measure, and so we define x as a random variable, right? It's a numerical measure of the outcome of a random experiment. So we have a random variable x, and we're going to define that in this case. You can define it one way or the other, but we're going to put it as the number of selected individuals who prefer football, and that's what we care about in some sense. So once we know that this is a random variable, we can say a few things. First, we can say that the smallest possible value of x is 0, right? That we're choosing 3 people, right? A random sample of 3 of these is selected. And so the number of selected individuals who prefer football, well, the minimum value that could take is 0. The next one is 1, right? Because we couldn't have half an individual who prefers football. That means that already we know this is a discrete random variable, right? X is discrete. And so that means that we're considering a subset of possible distributions. It's not continuous. Now, in the group, 7 of them prefer football. So of our 3, we know that, well, 2 of them could prefer football. That we selected, or 3 of them could prefer football. So this right here, this is the domain of x, 0, 1, 2, or 3, right? Those are the possible values it could take. If we choose other values of x, then the probability of that occurring is going to be 0. So we don't have to worry about that too much. What we want to know is the probability that exactly 2 prefer football, right? And the way to write this in mathematics is we want to know what this value is, right? The probability that x, which is the number of selected individuals who prefer football, equals 2. Okay. Now, if we didn't know some stuff, this would be pretty hard to do. But as it turns out, we actually do know some stuff. Let me see if I can. What we know is that we are drawing this value. Right? We're drawing x from a population of 10 individuals, and then we know what the underlying distribution is within that population, right? 7 prefer football and 3 prefer basketball. We also know how many we're going to be selecting, and so we can assign some values to this, right? Or some symbols, some variables here. We have as the size of our population is n. We're going to call that 10. Of those 10, the number of successes, we're going to define success. We'll call this a selected individual prefers football. This is a success. The number of successes that exist in the population, we use the symbol R for that. That's 7, right? We get that up here. We have 7. The number of failures in the population, and the number of people who don't prefer football, right? If we selected one of those and they don't prefer football, there are 3 of those in the population. And that's what the population looks like, right? Now we can talk about, well, our experiment. Our experiment is going to involve drawing a sample where we have n equals 3, that's the size of our sample, and then x is our random variable, right? So we're going to change the value of x. I'll put a question mark there because we're going to fill that in different places. In this case, we have a specific value of x, right? X equals 2. And so that's what we're going to use to start. But if we do this kind of experiment where we are drawing from a known population, and we have a probability of success or failure within the population, or we have successes and failures in the population, and we're drawing without replacement, right? So when we pull an individual out of this group, we're not gonna put them back, right? What we're doing is we pull them out, tell them, hey, can you stand over here to this side? And now we have 9 individuals left. Perhaps the person we pulled prefers football, perhaps they prefer basketball. We don't know, but whichever it is, it changes the underlying shape of the next 9. And then we select another one. Now we're down to 8, and finally we select a third one. We're down to 7. It could be the case that all 7 that remain prefer football, and we chose the 3 that prefer basketball. Could be the case that we got a mix of basketball and football, or it could be that all 3 that we chose prefer football. We don't know. That's what makes it random, right? Is that we don't know what's going to happen because we're randomly selecting these. But if this is the case, if we have this kind of experiment, then we know that X follows a specific distribution called hypergeometric. It's got a hypergeometric distribution, which is handy because we learned some things about the hypergeometric distribution. In particular, we learned the probability function for the hypergeometric distribution, and it looks like this. I don't know if I can paste it in here. Will that work? Let's try to. Nope, not that one. It would be handy if I can paste this so that I don't screw it up per chance. Okay, I'll just draw it for you. What do we have? Well, probability functions are functions, so we use function notation. What we have now is f of x, and then f of x in this case is going to be the probability that x occurs, right? The probability of x equaling some specific value is going to be given by the number of successes in the population, choose the number of successes we need to observe, times the number of failures in the population, times the number of failures we need to observe. Remember, if we see, in this case, we see, 2 successes, that means we need to see 1 failure because we have to fill out that third person. That third person has to prefer basketball. And those are going to be multiplied together and divided by big N, choose little n. The number of possible ways there are to draw our sample out of the population. Right? So that's the number of combinations of people we can draw, or of fans of football, fans of basketball we can draw. So that's we can plug this stuff in here. In our particular case, we have these values, right? So we're going to plug these in. So in this case, we're going to have 7 choose x times 10 minus 7 choose 3 minus x all over 10 choose 3. And if you want to pause and look at the values, the variables that I have over here and the variables that I have over here, you can kind of see where I pull these from. It might be worth kind of following along with your paper and just seeing, okay, do I see where he got all these numbers? Because that's very useful. You're going to need to know how to do that. Okay, now we have a specific value of x though, right? Because this is just a function, which is to say that if I plug in a value of x, it'll give me a value, a probability. And so what do we have? Well, if x equals 2, f of 2, well, that's going to be 7 choose 2. And then 10 minus 7, and I'm gonna reduce this here, is 3. Choose 3 minus 2, all over 10 choose 3. And this notation might not be that familiar to you yet. I highly recommend that you practice with it until it becomes more familiar. But this symbol, right? So let's say we have right here, for example, we have big N choose little n. What does that mean? This is a short way of writing it. But what it means is, or the way to calculate that value, it means the number of ways there are to choose n, choose n, little n out of big N. But it's calculated as n factorial, the big N factorial, divided by a little n factorial times big N minus little n, that quantity factorial. And what's handy to recognize is down here, this and this, if you add these together, you should get big N back out. Now, that doesn't mean you can substitute them, right? Because factorials, you can't, it's not like adding them together or anything. But it's a good check, right? So that when I expand these, what I'll have is 7 factorial divided by 2 factorial times 7 minus 2, that quantity factorial, right? And you can see that 2 plus 7 minus 2, which is 5, those will add up to 7. And so basically we're partitioning that total number of successes into the group we need and then the group that's left behind. So that's one of our values up here. The next one is going to be 3 factorial, and now I'm going to reduce this 3 minus 2 to 1, divided by 1 factorial times 3 minus 1, the quantity, factorial. And I'm running into myself here, I apologize. And then at the bottom we have 10 factorial divided by 3 factorial times 10 minus 3 factorial. Now, if this is pretty daunting to you, you're not alone, right? It is pretty daunting, right? There's lots of factorials, and factorials are something that are, you're probably not too comfortable with. They're pretty straightforward, right? 3 factorial equals 3 times 2 times 1, and 5 factorial equals 5 times 4 times 3 times 2 times 1. And so we know what they are, but how to play with them, and once you work on stuff a lot, you kind of learn shortcuts and you learn to feel more comfortable and more at ease with these things. And this might be unfamiliar to you. So let me walk you through the way that I generally deal with these. Usually what I do, okay, so we're going to move the whole thing down here again, is I do the denominator first, because I'm going to want to expand the numerator of these until I can cancel something out. And so this 10 minus 3, that becomes 7 factorial, right? And now I know, now this is handy to notice, right? So 10 factorial, well, one thing it also equals is 10 times 9 times 8, etc. So it equals 10 times 9 factorial, right? Because this 9 has all the rest of them. It also equals 10 times 9 times 8 factorial. And so there are lots of different ways to write this. Well, it turns out because we're multiplying just a long series of numbers, we can expand this until we can cancel something out. So we get 10 times 9 times 8 times 7 factorial. And we're going to stop there because we have a 7 factorial on the bottom. All right, so we're going to take advantage of that. And then on top, we're going to have the denominator here is 2 factorial times 5 factorial. And so we're going to do 7 times 6 times 5 factorial, because we'll be able to cancel out there. And then up here we have 1 factorial times 2 factorial, and so we're just going to extend this to 3 times 2 factorial. Okay, so let's take a deep breath. We've expanded our factorials, and so now we can take a look at this. We expanded them just so that we could cross some stuff out, right? This is to try to simplify things. This 5 factorial cancels out. This 2 factorial cancels out. This 7 factorial cancels out, which puts us in a little bit better shape, right? Now it's a little bit simpler. Down here we have 10 times 9 times 8 divided by 3 times 2 times 1. Up here we have 7 times 6 divided by 2 times 1. And over here we have 3 divided by 1. So what does that equal? Well, so 7 times 6, multiply that. You get, what is that? That's 42, right? Divided by 2 times 3. And then on the denominator we have, what is that? That's 10 times 9 times 8. That's 72 times 10 is 720. And then 3 times 2 times 1 is 6. So here we have 21 times 3. 42 divided by 2 is 21. 21 times 3 gives us 63 on top. And then the denominator is going to be 720 divided by 6 gives us, what is that? That's 120. Okay, so what does that equal? Hold on here. All right, Excel. You've got equals 63 divided by 120, 0.525. So what is that the answer to? So what we have then is f of 2, equals 0.525. And to interpret that, what we would say is, okay, well, our original question was saying, what is the probability that exactly 2 people of the 3 that we've chosen prefer football? Well, there's a 52.5% chance that 2 of these people prefer football. Okay, so that's how we do it, right? We work our way through this. Part B is asking what the probability is that a majority, which is say either 2 or 3, prefer football. The way that we write that is the probability, or one way to write it is that x is in 2 comma 3, right? So that those are the 2 values that we choose. Now, because these events are disjoint, right? Because either 2 will happen or 3 will happen, which is to say that they're mutually exclusive, right? That means there's no intersection. Then this is going to be just the probability of there being 2 plus the probability of there being 3. Okay. Now we already know what this one is, right? This is 0.525. But we're still going to need to figure out what this is. So let's take a crack at that. What's f of 3? Now we can rewrite our formula if we want. Hopefully you wrote it down the first time, but if not, I'll write it down again. There are possible successes of which we need to select x. There are big N minus r possible failures of which we need to select little n minus x. And then we need combinations of that out of a set of big N choose little n. In our case, we have 7 successes that are possible. And now x is 3, so we want to choose 3 out of those 7. There are 3 possible failures, people who prefer football, and we need to select 0 of those. And then out of the total, we're going to have 10 choose 3. Right? Okay, now I'm going to make this a little bit shorter by taking into account what the intuition of these things are. Right? So let's say that we have any given number of trials. Let's say we have y trials, and we want to get 0 successes. How many ways are there to get 0 successes in y trials? Well, you can think about this by the first trial, we need to fail, right? Or, yeah, let's just say there's 0 success. We need to fail, right? And then in the second trial, we need to fail. And in the third trial, we need to fail, and all the way through until the yth trial, in which we always also need to fail. Which is to say that the only way to make this happen, to get 0 successes in y trials, is to fail every time. And since this is the number of ways there are, this equals 1. Right? Similarly, and this is not going to be as useful, but that is also the case when you need y successes in y trials, right? Because you need to succeed every time, and so that also equals 1. Moreover, if you have 1 success in y trials, one way to do that is to succeed right off the bat and then fail every other trial. Another way is to succeed the second trial, fail all the rest. Another way is to succeed in the third trial, fail all the rest, and so on and so forth until you get to the yth trial. So if you have 1 success in y trials, then there are y different ways to get that. This is also true if you need only 1 failure. Right? Y minus 1. So y choose y minus 1 is also y. And so those are some handy shortcuts that can kind of help you. In this case, maybe it's not obvious, but it's going to be very handy right here, right? Because we know that 3 choose 0 is just going to be 1, right? In order to get 0 failures out of the 3 that exist, we're going to have to fail to get a failure, fail to get a failure, fail to get a failure. There's only one possible way to do that. So this is 1, okay? In addition, the bottom, well, we did that exact same one all the way up here, right? So I scroll up, 10 choose 3 is what we had, and we worked it out to here, and then we expanded it down to here, and then we expanded it down to here, and then again, bounce, bounce, bounce over to here, and we found that 10 choose 3, that's 120. So the bottom, we already know that's 120. Okay, now 7 choose 3, there's not really any getting around that, so let's convert that. That's going to be 7 factorial divided by 3 factorial times 7 minus 3 factorial. Okay. And so we're going to have to figure out what that is. All right, let's continue down here then. So I'm going to do the denominator first for that one. 3 factorial times 4 factorial. And now we're going to use the same extended trick. 7 times 6 times 5 times 4 factorial. So that's this part. Times 1. All divided by 120. Okay, what does that turn into? Well, we can cancel some things out here, right? This 4 cancels out. And now we have 7 times 6 times 5 divided by 3 times 2 times 1 times 1. We can keep it there or omit it at this point because it's not going to change anything. And that gives us, well, what does that turn into? Well, 7 times 6 times 5 divided by 6, right? We can just kind of actually cancel these out as well, right? So 3 times 2, cancel that out and cancel this out. We're going to get 35 divided by 120. Now what does that equal to? Well, bust out your calculator. 35 divided by 120, 0.2916666, etc. 0.292, we'll call it. So f of 3 equals 0.292. And now we needed that, right? What we needed that for was this, right? Because this is what we care about. This is what we were trying to answer. So I can take this, put it up here, plus 0.292. So what does that equal then? Let's move down here. I lost it. Is there a way to just barely? There we go. So we're going to have the probability that x is either 2 or 3 is equal to 0.525 plus 0.292. You can use a calculator for this. I like to try not to. We have 7 here. 2 and 9 is 11, carry the 1. 1, 5, and 2 is 8. So what is the probability that a majority prefer football? 0.817, which is to say an 82% chance, roughly, that a majority prefer football. And there we go. We can go back up here. We know that the probability that exactly 2 prefer football, this was 0.525. And the probability that a majority was 0.817. So that's how you do it. Hypergeometric distribution, right? You need to know what that distribution is, and usually you'll have a formula sheet that'll show you. But then you also especially need to know how to deal with these, right? Which involves converting these into factorials and then how to deal with factorials. I hope you found that useful. I recommend that you practice, right? Practice is really the way to get good at this stuff. And then after a while, it'll start to seem old hat, and you'll feel like a really smart person. So, if you have any questions, as always, I'm glad to hear them, and hope that helped. See you guys later. Bye.